Hello everybody. Let us discuss today another important topic, constraint optimization and producer equilibrium. So we know that a producer always wants to optimize his output and minimize his cost so that profit is more or profit is maximum. Now he is often interested to find out the least cost combination of inputs and profit maximizing level of outputs. So if he produces a commodity using two important inputs, so what will be the least cost combination of these two inputs and what will be the profit at this level? So constrain output maximization at least cost, or you can say constrain output optimization at least cost. So let his output function or production function, it is the function of two inputs x1 and x2. So Q is output, x1 and x2 are inputs, and constraint is equality constraints is cost function, that means the cost is the constraint. So total cost C0 is equal to R1 x1 plus R2 x2 plus B. So this is the variable cost spent on x1, and this is the variable cost spent on x2, and this is the fixed cost. So B is a fixed cost, and summation Ri xi. So I ranges from 1 to 2. Ri xi is the variable cost. Now the constraint function P is equal to function x1 x2 plus mu C0 minus R1 x1 minus R2 x2 minus B. So if we transfer these terms towards left side, C0 minus R1 x1 minus R2 x2 minus B. So this will be equal to 0. So let us put mu is multiplied by this. Now differentiating delta V by delta x1, then delta V by delta x2, then delta V by delta mu, and as this is as first order condition, then move price term to the right, then first two equations and multiply the first equation by the second equation and equate to price ratio, then first order condition of optimization will be F1 by F2 is equal to R1 by F2. So we have already discussed several times in utility maximization is that. So same thing. So here we can delta V by delta x1, then delta V by delta x2 is equal to delta V by delta x1 will be equal to F1 minus mu R1 is equal to 0, put to 0, first order condition. Then delta V by delta x2 is equal to F2 minus R2 x2, mu R2 is equal to 0. And delta V by delta mu is equal to C0 minus R1 x1 minus R2 x2 is minus b is equal to 0. Okay. Then first equation divided by second equation, we will get the first order condition f1 by f2 is equal to r1 by f2. So meaning is that the rate of technical substitution is equal to the price ratio of inputs. So technical substitution, the marginal rate of technical substitution, MRTS, marginal rate of technical substitution. So this is also known as the slope of the isoquant is equal to the price ratio. In other words, the slope of the isoquant curve is equal to the slope of the isocost curve. And so C naught is the cost. So its first derivative will be equal to the slope of the cost curve, or we say marginal cost curve, the slope of the isocost curve, and at this point of equilibrium the output is maximum, or we say it is the optimum output at the lowest cost. So input combination will be optimum, it means it is least cost combination. So second order condition is that bordered Hessian determinant should be positive. So we have got earlier that if first order is negative for maximization, second order condition, the bordered Hessian determinant should be positive. Now in the figure, so optimum level of inputs. So this is the isoquant, and this is the isocost line. So both the curves are tangent at E. So when it is equal, tangent of isocost curve, isoquant, f1 by f2, isoquant or RTSC, rate of technical substitution is equal to price ratio of the inputs. So this is the R1 by R2, this is the slope of the isocost line, and f1 by f2, this is the slope of the isoquant. So they are equal at a point E. So corresponding to this point, OX1 bar and OX2 bar, these are the two levels which will be the least costly. So putting these values of x1 and x2 in the production function, we can in the production function, we can find out the optimum level of output. Let us give one example of utility function having the equality constraint. Suppose utility U is the function of Q1 and Q2, and the form is given here, Q1 into Q2. The function is specified, okay, function of two commodities. Now budget constraint, the consumer has budget constraint, that budget is not unlimited, so budget is limited and it is exhausted equal. Expenditure on Q1 and expenditure on Q2 is exactly equal to his income. That means what he has in his pocket, it is equal. So 2 is the price of Q1 and 5 is the price of Q2. Now we have to maximize the utility. So the person, consumer, wants to maximize its utility. So the constraint function is P is equal to Q1 Q2 plus lambda 100 minus 2Q1 minus 5Q2. Now what will be the necessary condition? F1 is equal to delta P by delta Q1 is equal to Q2 because it is multiplication. So coefficient of Q1 is Q2, Q2 minus lambda 2 with respect to Q1. So let us put it to 0, first order condition or necessary condition that first derivative should be put to 0. Then second derivative with respect to Q2, delta V by delta Q2 is equal to Q1 minus lambda 5 is equal to 0. And delta P by delta lambda is equal to 100 minus this. 100 minus 2Q1 minus 5Q2 is equal to 0. Now, so we are putting F1 is equal to 0, F2 is equal to 0, and with respect to lambda is equal to 0. Now, what is the second order condition or sufficient condition? Or would you say that F11 should be F11 we have found it is 0, F22 it is 0. Okay, because F11, if we differentiate this with respect to Q1 again, because there is no Q1, so that's why it is 0. F22, there is no F2, sorry, Q2, there is no Q2, so it is 0. F12, now here, you see Q2 is there, so F1, 1, 2 means the first derivative of this, then taking the, what result we are getting, we have got this result Q2 minus lambda U2, so you differentiate again with respect to Q2, that will be F12. So this is 1, coefficient is, power is 1, so it will be 1. Then second order condition or sufficient condition states that 2F12 F1 F2 minus F11 F2 square minus F22 F1 square should be positive. Now we have seen that this term F11 is 0, so this term is 0, F22 is 0, so this term is 0, only this term is positive. So the sufficient condition is satisfied. That means the utility function is maximized as sufficient condition is satisfied. We can solve. So since it is maximized, that means sufficient condition is satisfied, then we can solve Q1 is equal to 25 and Q2 is equal to 10. Okay, Q1 is equal to 25 and Q2 is equal to 10. Then consumer equilibrium is attained when slope of the indifference curve F1 by F2 is equal to the slope of the budget line. So F1 by F2 is the slope, F1 by F2 is the slope, and that means F1 by F2, if we divide this by this will be F1 by F2. So F1 by F2 is equal to the slope of the budget line. Their tangent at point E in the diagram, their tangent at point E when F1 by F2 is equal to P1 by P2. So this condition is satisfied at point E. So as we have already discussed in production that the quantity of Q1 corresponding to the point E and quantity Q2 corresponding to point E is the optimum combinations or optimum level of output or commodities that the consumer is going to buy to which will maximize his utility. So the figure is a general geometrical representation of a consumer equilibrium showing indifference curve, budget line and the point of tangent at E. So this is all about the optimization of output subject to some subject to cost with equality constraint. Thank you.